session. Uh, please let me know in the chat box that you can hear me clearly. Please let me know once again that you hear me clearly so that I can start the today's session. You can send a message in chat box so that I can start the last part of today's session. Please let me know. There are four people. So yes, I have received a message from Mr. Safi Ajam. All right, let's start the last part of our today's session. This is quantitative primary data analysis. Myself, Zahid Kashif. Today is 13th January 2024, and we are on intermediate level of our training session on SPSS. And what we need to learn today, we have also availed the 10 minutes break. In this session, we will going to learn the first 6 cases or first 5 cases of our regression analysis. The remaining cases will be dealt tomorrow along with the Hayes process. So you need to understand what are the 10 cases of regression, because learning the cases would make you able to interpret your results carefully, and there is a slight difference between each analysis of regression. In case of simple regression analysis, you can have a quantitative independent variable, you can have a quantitative dependent variable. So whenever you are using your independent and your dependent variable as a quantitative, both are quantitative, you does not require any special procedure or any special treatment of your simple regression analysis. Similarly, if you have more than one quantitative independent variable, quantitative means here which is measurable or which is not categorical, which is not binary, which is basically it might be continuous. uh, so whenever your independent variables are more than one and they are quantitative, and you are going to see their impact on dependent variable, you are dealing with multiple regression analysis. That is the second case. In third case, the situation slightly changed. It is a simple regression analysis where you include a dummy variable. Your independent variable might be binary. Like in case if we would like to know the impact of gender on some dependent variable. So gender is basically a binary variable uh, where we can indicate male is equal to 1 and female is equal to 0. So in case where your independent variable is binary, you are going towards the case 3, and your dependent variable is still quantitative. So I will elaborate all these cases one by one, but at first you need to have an overview that what these cases are. In fourth case, you need to have your independent variable with more than two categories. So whenever you have more than two categories in your independent variable, or your independent variable is having an independent variable with more than two categories, there is a slightest change in your regression analysis. In the same way, you may consider the binary logistic regression, where your independent variable may be quantitative and your dependent variable may be binary. So whenever your dependent variable changes, you may need to change the thorough procedure of your analysis. You may need to analyze your data in a more complicated way. So in case of binary logistic regression, your independent variable might be quantitative and your dependent variable might be categorical, like it may be binary. In case of the sixth case, you are using the binary logistic regression, your independent variable may be binary and your dependent variable may still be binary. In case of seventh case of regression, you may have a categorical independent variable, but your dependent variable need to be binary. So whenever your dependent variable is binary, you are going towards the binary logistic regression. So case number 5, case number 6, and case number 7 are basically related with binary logistic regression, where your dependent variable is binary while your independent variable might be quantitative, might be categorical, or might be categorical with more than two categories. And then in case number 8, you are going to watch multiple logistic regression. Case 8, 9, and 10, they are related to multiple logistic regression. The difference between binary and multinomial logistic regression is that the dependent variable is changes. In case of binary logistic regression, the dependent variable is binary. While in case of multinomial logistic regression, the dependent variable is categorical. It means there are three categories of your variable in case of multinomial logistic regression. So in case number 8, your independent variable would be quantitative and your dependent variable would be categorical. In case number 9, your independent variable might be binary and your dependent variable would be categorical. And in case number 10, your independent variable might be categorical and your dependent variable may also be a categorical. So we will analyze these cases one by one, and we will come to know how the analysis can be done. So as a first step, I will analyze a simple regression with quantitative independent variable and quantitative dependent variable. And you can interpret the results in the same way as we have done previously. So what we need to do, we need to open a data and we need to run a simple regression analysis. And both IV and DV needs to be quantitative. It means they both are neither categorical and they also are neither the binary variable. They both are continuous variable or interval scale variable or ratio scale variable. So whenever we talk about the quantitative, it means ratio scale or interval scale variable. So these type of variable are called quantitative variable. I can share again. We can simply copy it from here and we can put it over here. So in case our independent and dependent variable both are ratio scale or interval scale, we can use the first case. So we can take a dependent variable and we can take an independent variable for simple linear regression analysis. In this way, we can run this procedure. You can take only one variable. For example, I would like to find out GPA on the basis of total. So whenever you have both the variables quantitative, how can we understand this is quantitative variable? There is a simple rule. You can go to the variable view and you can find out the Meyer column. If the Meyer column indicates nominal or ordinal, it means they are not quantitative. Those variables with the scale as a measurement are quantitative. So you can see that ID is quantitative. You can see that year is quantitative. You can see GPA is quantitative, and you can see quiz 1 to quiz 5 is quantitative. Final marks are quantitative. Uh, and then total marks are quantitative, percent marks are quantitative. In addition, Z scores are quantitative, although they are not required over here. So we need to select the dependent and independent variable which are quantitative. So we can take GPA as a dependent variable and we can take, for example, total marks as a independent variable because both are quantitative. So we can go analyze, we can go to regression, linear regression, and we can put the GPA as a dependent variable, and we can take the total marks as a independent variable. You need to check whether is there any option which is being checked here. You need to basically uncheck the other procedures because those procedures are not required. Here you can find the standard is checked. You need to uncheck this, and you need to find out if the others are also. So you need to click OK button, and you will find this result. So these are the result of case one, where your independent variable and your dependent variable both are quantitative. So simply you can simply you can simply interpret them in the same way as you have done previously. Like you can interpret the R. R is basically the correlation between independent variable and the dependent variable, and we can say that there is a weak positive correlation between GPA and total. There is a weak positive and significant correlation between GPA and total marks. Then there is a R square which is 18.7%. If we multiply this value with 100, we can find out it is 18.7%. And we can interpret that the variable total marks is explaining the variance in GPA about 18.7%. Then we don't need to interpret the adjusted R square or standard error of estimate. Then we need to see the ANOVA table. If the sig value of ANOVA table is less than 0.05, we can say that our model is statistically fit. So in our case, the sig value is less than 0.05. So we can conclude here that our model is statistically significant. Then we come to the coefficient table. Here you can see the beta value of the beta value of the coefficient table is 0.022 unstandardized beta, and if we are considering the standardized beta, it is 0.432. It is still positive. So we can say that there is a positive impact, and you can see that the p-value of this impact is greater than 1.96, and the p-value is less than 0.05. So we can say that there is a positive impact of total marks on our GPA. This is the way you can interpret a simple regression analysis where your independent variable and your dependent variable both are quantitative. So we can conclude here that with the increase of total marks, our GPA would also increase. So this is the conclusion of case one. So I hope you understand our case one with this. The next one is the multiple regression analysis. When you have more than one independent quantitative variables and you have one dependent variable. So in this case, your independent variable would increase while your dependent variable will be single. So this is the case of multiple regression analysis. You simply need to add more independent variable to run this procedure. You need to go to the linear, and you need to put more independent quantitative variable over here. Here you can see final is also quantitative variable. You can see total is already there. You can see that percent is also a quantitative variable. So let's suppose there are three independent variables. So it is meeting the requirement of our multiple regression analysis with more than one quantitative variable. So independent variable are more than one and they are quantitative, and our dependent variable is already quantitative. So we need to run this procedure. We need to click OK, and you will find the regression tables like this. So how can we interpret? You can see that the R has increased. Previously, when we had one independent variable, we have a smaller value of r, which was approximately 0.432, and r square was 18.7%. But now the r along with r square both have increased. You can see the correlation between all of these variable is uh, strongly positive. This is a strong value. We can say there is a strong positive and significant correlation between percent final total and GPA. And we can also see that are independent variable, which is percent, final, and total. They are explaining the variance in GPA about 25%. So about 25% of variance in GPA is explained by percentage, by final marks, and by total. So these three variables are combinedly explaining 25% of the variance in the GPA. Next is our ANOVA table. If you can see, our table indicates that our model is statistically fit. And we can conclude here that as the value of ANOVA sig value of ANOVA is less than 0.05, so we can conclude here that our model, our regression model, is statistically fit. Next is basically the coefficient table. Here you can see that you have only one variable which is statistically significant, while the other two variables are insignificant. So the final marks variable is being positively impacting, and the p-value is 1.96 and the p-value is less than 5%. So we can say that the final marks uh, is significantly increasing the GPA. While if we see the row containing the total marks, it will indicate you that it is negatively impacting your GPA. So it means GPA is decreased by total marks, but it is not significant because the p-value of it is less than 1.96 and the sig value is greater than 0.05. So we cannot say that the total marks is negatively impacting the GPA because it is insignificant. So we can conclude here there is an insignificant negative impact. There is an insignificant negative impact of total marks on GPA. So GPA is insignificantly decreasing by total marks. So in case of percentage, you can see there is a positive impact, but still this impact is not significant because the p-value is less than 1.96 and the p-value is also greater than 5%. So we can conclude here that percentage is insignificantly increasing the GPA. So only one variable basically have a significant role in increasing GPA, while the other two variables does not have any significant role in increasing or decreasing the GPA. So this is the way you can basically interpret your second case multiple regression model with more than one quantitative variable and one dependent variable. Now we are coming towards the simple regression analysis with dummy variable case. If we are having a categorical or binary variable like quantitative, how can we deal it? If we can see this data set also have a gender variable like male, female. So we can simply either we can create the dummy variable over here. We may have other categories of variable like native, Asian, black, white. These are more than two categories. So when we are dealing with only two categories, it is binary. But whenever we are dealing with more than two categories, it is a dummy variable category or binary variable category. So in case number three, we need to analyze independent variable as a binary and dependent variable as a quantitative. So how can we analyze our binary variable as an independent variable on our quantitative dependent variable. So let me explain you the procedure. You just need to go to transform. You need to create your dummy variables, like you can create dummy variables over here. You can put the gender into create dummy variables, and you can write here the gender again. All right, and you need to click OK. It will automatically create the dummy variable, and if you would like to see whether the dummy variable was created or not, you need to wait over here about the variable creation. Here it has created gender 1 and gender 2. Gender 1 is related with females and gender 2 is related with males, and you can verify it over here. This is gender 1, which is related with female. You can also edit from here. You can put here this variable is related with female. So here they have taken female as a priority gender variable, and in the second case, gender 2, they have taken male as a priority gender variable. So you can take here the male, and we can also verify their values if we see the data view, and if we basically check our last two columns. You can see in case of female, when there is a female respondent in our data, you can see one here, and in the remaining cases there is a zero. It means whenever the respondent uh, was a female, it is indicated by 1, and whenever the respondent the response was conducted by the male, it was placed 0 whenever there is a dummy variable for female. And whenever the dummy variable is for male, you can see when there is a female, it is automatically coded by 0, but when there is a male, it is automatically coded by 1. So how can we analyze our data? There is a very simple rule. If you want to create just a gender variable, you need to put it over here. Just a minute. You need to put it over here as a gender. Just put here just a gender. If you see, they have created one for female and two for male. If you have some priority in your mind regarding the gender, if you want to analyze the impact of female only, you can take this dummy variable. And if you want to analyze the impact of male only, you can take this variable as an independent variable. If you want to consider them as a binary, you can create new gender variable where you can put your values over here. You can say that if you want to analyze one for the female and 0 for the male, it becomes binary now. Now you can place your values over here. If you are considering 1 for female and 0 for male, like I have done this over here, 0 for male and 1 for female, you can simply copy the data related to female because it is indicating 1 for female and 0 for male. So this is the way how you can create uh, a binary variable. If you would like to see the impact of female, you can use this variable. If you want to see the impact of male only, you can use this variable. And if you want to see the impact of gender, you can use this variable, but you should not use the gender of this variable, because it is indicating one for uh, female and two for male, and it is something like a categorical variable. This is not a binary variable. In our case, we require a binary variable with 0 and 1 as a binary indication, so we need to convert them as a binary condition. So this is the new binary variable. So one by one I need to let you know how the analysis can be performed. You simply go to regression. This is linear regression. You simply put your DB over there. Let's suppose I would like to see the GPA on the basis of both of the gender, like how much is the impact of female and how much is the impact of male. This is basically not the binary impact, but this is the individual gender impact, that how they are impacting the GPA. So I can calculate it using OK button, and you can see the R is 19.4, which means uh, they have computed gender. Sorry, this is basically the result. I think we have taken the gender male. Gender is equal to male, and this is the male result. So if we can see variable, this is gender male, this is gender female. I think we have taken the last two one, so we should analyze it again. Regression, linear, gender male, gender female. We have taken the right one. Why it is not? All right, we can analyze it one by one. Like for first we need to analyze the gender as a female. So click OK. You can see predictor as a gender female, and you can see the R is 19.4%. It means there is a weak significant positive correlation between female and their GPA. So if we have female, we might have a weak correlation with the GPA. The R square is very low. It indicates only 3.8%. It means 3.8% of the variation in GPA is explained by the females. So the model is also statistically significant with these combination of variables, and you can see there is a positive impact. There is a positive impact which is statistically significant. We can say that the female as compared to male, because we are comparing them. So female as compared to male having more marks. If this value is positive, it means they have more marks as compared to the other category. So we can say the females having 0.302 more marks than male, and it is statistically significant because the p-value is 1.96 and the sig-value is less than 0.05. So we can conclude here that there is a positive and significant impact of female on the GPA marks, and the females have more marks than the male, which is basically referred by 0.302. So in the same way, you can also run the same procedure on the male category. Like you can go to the regression, you can go to the linear, and you can replace the gender female from here, and you can put the gender male over here. So you can run this procedure again, and uh, you can see the results. It's still the same R square, and you can see the same sig value and same gender value. So as per our requirement, we should have a binary independent variable. So we need to take the new gender variable like this, because it is indicated whenever there is a female, it is indicated by 1, and whenever there is a male, we have indicated it by 0. So we need to take this as an independent variable for calculating its impact on GPA. So we need to analyze it. We go to the regression, we go to the linear regression, and we need to put it the new gender as a variable, as an independent variable. Now it is binary variable. So as per our requirement, if we see the case number 3, it is indicating that your independent variable need to be binary and your dependent variable need to be quantitative. So in this way, we can match with this condition. We need to click on OK button, and we will find out these results, and we will find out the same results over here because females are there. So again, it is showing that there is a positive impact of gender on GPA, as the gender is basically representing by females more as compared to male. So we can conclude here that females are significantly impacting the GPA score as compared to male. So this is the conclusion of case number 3. Now moving towards case number 4, which is somewhat more complicated case, and this is the last case of our today's session, and you will need to understand it thoroughly because it will create the base of our remaining cases like case number 5, case number 6, case number 7, case number 8, case number 9, and case number 10. So if you carefully understand the case number 4, you will be able to understand the remaining cases, because this case is a complicated one. It has a lot of steps that need to be applied. So you need to be very careful in understanding these steps in case number 4. The first 3 cases were simple. There is, I don't think that there is any value addition in the first 3 cases, but in case 4, you might have some value addition because your independent variable is going to become categorical, and your dependent variable is going to become quantitative. It is still quantitative like in previous cases, but your independent variable is becoming categorical. So whenever you have more than 2 categories as your independent variable, you need to create dummy variable. If you have 3 categories, you need to create 2 dummy variable because one category is considered as a reference category. If you have 4 categories in your independent variable, you need to create 3 dummy variable. If you have 5 categories, you need to create 4 dummy variables. So you need to understand how different categories would be applied over here. So I can take a very simple example. Well, I will use the same data set, and I need to identify the categorical variable. So first you need to understand that a categorical variable is something that have more than 2 categories. You can see here ethnic is a categorical variable because it has more than 2 categories. It has actually 5 categories. So you can create 4 dummy variable over here because you need to assign a reference category for one categorical variable, one of the category. You can also create a categorical variable over here. You can create dummy variable over here because you have more than 2 categories over here. You can also see, but in this case, in case of section lower and upper, you have only 2 categories. So you can create a binary variable over here. You cannot create the categorical variable here. So this condition is related with case number 3. You can create just a binary variable from here. You can create a dummy variable for lower. You can create a dummy variable upper, and you can combine them as a new section variable. So it is not related to case number three. You can go this here. You can also do the same procedure, the case number three procedure here, because it is looks like a binary. You can convert them as a binary, and this variable name is basically the extract or extra credit. The next one is related with, again, it is also the binary variable because there are two categories. So you can create categories if there are more than two categories. You can consider it as a case number four. So what is the procedure? You need to understand it. I will thoroughly explain the procedure over here. First, you need to go to transform, then you need to select recode into different variables. This is basically when you are dealing with a categorical variable. When you have more than two categories, you need to select recode into different variables from transform. You need to select it over here. The one which category you basically want to make it there. Let's suppose I would like to consider ethnic group as my categories. I need to see what options do I have. I have native option with one. I have Asian option with two. I have black option with three. I have white option with four, and I have Hispanic option with five. So I have five categories. And remember, always remember that how many categories do you have? You always consider one category as a reference category, and you can create dummy variable after subtracting that one category. So in this case, if we have five categories, we can create four dummy variables. So let's have a first dummy variable on the basis of native. So how can I create? I go to transform. I go to recode into different variable. Uh, I can select by clicking on this, and I can find out from here the ethnic group. You need to put your categorical variable here, and you need to tell for which category you basically want to create your dummy variable. So first category was native as per our requirement. The first category is native and its original value is 1. So I can create here dummy hyphen native, and you can create the hyphen NAT. It is the short form of the above name. And what you will do again, you need to click the change button, and it will convert your ethnic into your dummy native variable. And then you need to click on old and new values. The original value of native was the original value of the native was 1, and you want to measure its impact. So you need to put 1 again, because 1 basically means that you are measuring its impact, while the zero means that you are not measuring its impact. So original